Good morning, everyone. I'm Han-Chieh from National Donghua University. I'm so delighted to be invited by Professor Lü Fangze to join this marvelous conference, which is to be held in Taichung, Taiwan. The Future ICT2021 is a very prominent conference, and it will be really my privilege to deliver a keynote speech regarding what I've been doing for the past decade about 5G, even beyond 5G or 6G.
So before I formally start my talk, let me briefly introduce about myself and the campus I'm now serving. I'm currently serving as the president of the National Donghua University, and I have been chosen to serve quite a lot of distinguished journal as an editor-in-chief or associate editor. And I have awarded several good awards, of course. For example, Survey Paper Award for Gold Survey Paper Award in 2020, Best Paper Award, and a lot of other things such as HCIS, Human Computing Intelligence Systems Award for 2017, and other things. And also I'm so honored to have the IET Network Premier Award in year 2014 and the IET Widely Sensor System Premier Award for 2016. Where is my campus? Okay. My campus is located in the east side of the Taiwan, which is about 2.5 to 3 hour bus plus train distance. So it's not that far away from the international airport, and I'm sincerely welcome all the attended for this conference after the COVID-19 outbreak. Well, you are all welcome to my campus, because the left down corner is a picture taken live on campus, which is showing that Donghua University is the most beautiful university in Taiwan. And we have a college. That means Donghua University is a very comprehensive university, of course. And Donghua is only 26 years old. However, we are ranking number 10 in Taiwan, which totally around 160 universities in Taiwan. And there are several other rankings from Times, provided from Times, such as Impact ranking, we are number 5, Asia University ranking, we are number 12, and Emerging Economic University ranking, we are number 16. Young University ranking, we are in the world 200 to 250. I guess the most important thing need to be mentioned is for subject ranking. In year 2020, for computer science, which I'm belonging to, is ranked as number 6 in Taiwan, and engineering and technology is ranking number 8 in Taiwan. But more than this, several weeks ago, 2021 subject ranking has been released. Our computer science has been moved one place up to number 5 in Taiwan. For a 26 years old young university, I guess we are doing not that bad. Some other rankings showing that Donghua University is keeping steady in certain range ranking. So we are not especially outstanding in only one ranking, but several rankings are almost the same, such as U.S. News Asia QS ranking and the Brown University ranking from Moscow. Here's a particular look of our campus, which has been newly finished building for the College of Arts. Okay, after some sort of self-advertisement, let me get back to my talk. Here's the outline of my talk, and I will skip several parts, or I will a little bit speedy on several part of my talk, because I guess most of you are quite familiar with part of my talk. So I just roughly bring you some ideas regarding the progress of what wireless communication currently have, but concentrate on the learning platform, deep learning platform for beyond 5G mobile network we had established 2 years ago. Okay, let's start it. Here's the wireless communication, and as we always know, we are limited using those spectrum. So whenever we need to upgrade from 3G to 4G, 4G to 5G, we have to squeeze the spectrum and try to find out particular range of those spectrum for particular use. That's the reason why for 5G, the vendor, service provider, or the vendor trying to move a little bit up to the millimeter wave, so that we can, in that particular range, can provide more spectrum for service provider to use. And what a coincidence, each generation, the separation for the time gap between each generation is about around 10 years. But I'm certainly quite sure for the 6G or beyond 5G, it should be less than 10 years, because I guess United States trying to push very hard to move to 6G as soon as possible. And of course, here are some from 1G to 3G to 4G. I guess for 4G, we are trying to connect everyone together, or should connect everyone into the internet. But for the 5G, we are trying to connect everything together. So besides the voice, message, internet, multimedia, there will be quite a lot of application regarding Internet of Things to be connected into the 5th generation. As predicted, we always know in year 2021, there will be more than 28 billion devices connected to the internet. Within it, only 13 billion belonging to mobile phone, PCs, those traditional mobile devices. However, the rest of the 15 billion will be all kind of different IoT devices, like a self-driving car or robots, and even the solar cell. It can be intelligent, connected to the internet. Quite a lot of important company has made up their mind, made their own progress on 5G trend. And also there's a so-called next generation mobile network group. They design a principle separated into radio for network and operation and management, So for each division or for each section, there are several topics need to be dealt with, such as for network, they are create common composable core, minimize the number of entity and functionality, things like that. Here are some next generation mobile network. They're trying to build up an ecosystem and guidance to E2E architecture and evaluation tests and proof of concept result is also very important. Here are those companies and even the university who joined the NGMM group. And there is another group called IMT2020 Promotion Group. It's a major challenge. They designed a major challenge for future IMT systems. You can take a good look. I guess we all come to a very unique or come to the same conclusion with the demanding for higher user experience data rate, of course, and zero latency as small as possible. And that means as small as possible and higher density of connection devices, higher traffic volume density, higher mobility, higher energy efficiency. All those factors are very important for 5G, and we are doing very hard to meet these demands. So for IMT 2020, of course, their technical performance requirement has a requirement based on the key capability, and there will be 5 additional requirements for peak spectral efficiency, reliability, bandwidth, things like that. So if we can really achieve what they require for IMT 2020, I guess for those 8 requirements, we can meet the requirement pretty well. However, for the 5th generation or for the user, there are all kinds of different demanding, such as for the right up corner, for immersive 360, for those VR, AR user, they are demanding throughput to be very high and high, but the latency is around 50 to 100 milliseconds, reliability is medium to high. However, if you are dealing with those industry robotic, the throughput is very latency demanding to be much lower to 1 to 10 milliseconds. Reliability should be very high. So there are 3 different demanding, briefly divided into 3-4. One is ultra reliable low latency connection, and the second one enhanced massive bandwidth mobile bandwidth requirement, and enhanced mobile machine type connection. These 3 different factors or 3 different sections briefly can cover all kind of users' demandings. Here are the 3GPP 5th generation going on. Currently, we are 3GPP in 2020, July 3rd, 2020, already released R16 being finished. That means 2020 in June 30, 5G for the first standardization protocol is ready by June 30th, and so therefore all those vendors can start to deploy the 5th generation, follow those 3GPP protocols. And of course, next new radio needs some other technology besides LTE, because they are demanding those spectrum from 6 GHz as high as to 100 GHz. That means a millimeter wave. So next radio will choose OFDM as their medium connection medium. And several technologies, of course, been bring forward, such as scalable OFDM-based air interface and the flexible bit-based framework. And in August 2016, 3GPP has agreed to using CP-OFDM as the 5G new radio uplink downlink waveform, the main waveform. So we have advanced channel coding, so they can be utilized for all different kind of frequency demanding or speed demanding, such as when you are broadcasting, or when you are a household, when you are in a household, or when you are driving a car in a high speed. So that's another is MIMO. Okay, MIMO you can using quite a lot of antenna to using beam focus, so you can effectively reduce the delay and low down the expense, of course. And you can using the mobile millimeter wave and beamforming, beam tracking enable wide millimeter wave bandwidth for extreme capacity and throughput, of course. Several functions have been introduced, such as authentic server function AUSF, and access and mobility management function AMF, and the data network DN, and structured data storage function UDSF, network exposure function NEF, network repository function NRF, network slice selection function NSSF, and the policy control function PCF, and so on and so forth. There are quite a lot of new functions being introduced. So that's based on the 3GPP TS23.501. It's the system structure, including those all those network functions. And based on the Release 16, we are using 5G new radio and licensed spectrum will be using, along with licensed spectrum. So that that means we are trying to use every bit available spectrum. In the 4G 3GPP Release 12, formally define LTE-U to, that means LTE-unlicensed. And so for the 5G, is follow those Release 16 and being improvised or being enhanced in Release 14, and therefore we have bring those into so-called LAA technology. It will be even better than LTE-U. Release 16 has several features to improve the MIMO efficiency and functions, such as enhancing the multi-user MIMO to support higher ranks, and supporting multiple transmission and reception point, and better multi-beam management, improving reference signal to reduce peak to average power ratio, and extending uplink coverage, things like that. So in order to broaden our application, or such as being used in the factory automation, with demanding the extra reliable, extra low latency, such as URLLC. For this kind of requirement, Release 16 also include the so-called supporting 99.9999% reliability upgrade, and at the same time trying to maintain millisecond latency. So trying to renew the E-URLLC can do something like that by using coordinate multi-point COMP communication and spatial diversity and channel polarization, and those kind of technology being introduced. So the increased redundancy and more reliable, flexible scheduling can be expected. Since 5G is going to be using millimeter wave, of course, we are expected it will be even more power consuming than before. Therefore, power efficiency will be a very important issue here. Release 16 will bring in several power saving function features such as wake up signal, and so that your devices can beforehand know when to stop the transmission and when to go into the low power consumption mode, or jump to the next discontinuous reception mode, so we can save the power. And at the same time, those features are trying to also enhance the mobility handoff, so that you can predict your handoff function, so that when you're doing those handover, you can reducing your interruption time, and by using those conditional handover or those report beforehand, and then for master cell group area coverage technology can be used as long as we are doing the handoff. And Release 16 also trying to expand the 5G network coverage, so and extended the public networking coverage supporting, and that's the another major feature of 5th generation. That means we are going to provide massive connection for Internet of Things. It's very, very useful when you are trying to deploy IoT. So Release 16 can also provide those time-sensitive networking to meet their requirements. In order to merge those time-sensitive networking stuff, we are going to do our best try to minimize those wireless connection, random radio access network, what their influence regarding those time-sensitive network or time-sensitive demanding. So therefore, we can have a time-determinist packet delivered. So also, Release 16 provide those new interference measurement technology. A very stable deployment will be established, and base station to the end user devices interference will be mitigation, and time division duplex will be even more easily to achieve. And Release 16 also including some sort of 500 MHz unlicensed spectrum downlink using for and 100 MHz uplink upward using that kind of a connection requirement, and that so before then this kind of connection has already been provided for vehicle to everything, okay, communication vehicle to everything for safety purpose. And Release 16 using those network new radio as a basic to provide coordinate driving, and such as we can using the multicast communication and on the fly multicast group, and also at the same time distributed synchronization for QoS purpose. For those technology being introduced, new kind of feature can improve self-driving car, the safety and efficiency of the safe driving car. So here are the brief summary regarding what we are demands for fifth generation. I guess everyone should be very familiar with that already. And I have to mention that this paper has been cited more than 250 times. So if you are very interested on fifth generation, you should take a good look at this paper, the 10 key enabling technology for fifth generation. And multi-stream aggregation can be achieved through 3 different technology, like boosting sublayer, aggregate all the stream, and so that user end can obtain the most benefit from using this kind of boosting RAT and boosting port and boosting carrier stuff. And I guess mainland China already using the CRAN. I will skip this part. And for edge computing or fog radio access network is very demanding for the fifth generation, because we are trying to achieve low latency purpose. So there are some sort of introduction like this. When you are using normal speed, of course you are using the traditional connection through CRAN. But however, if you are in some particular position, you're using D2D mode, or maybe using some sort of coordination mode, relay mode, sorry, and then finally using the coordination mode, local distributed coordination mode. So here are the fog radio access network example. Of course, we are going to experience all kind of handover in fifth generation, or even in beyond 5G. Network slicing will be very, very important for 5G, because we're going to demanding flexibility and computing, heavy computing, and all that stuff, and also meet the requirement of the industry 4.0. And flexibility is very important. So therefore, network slicing is very perfect choice for us to be chosen to provide it, to provide those kind of innovation. Based on the TS 2022.261, network slicing will allow the vendor to provide network connection to different kind of demands or requirement, such as priority, rating, policy control, safety, and mobility. And also there may be some difference between what you require, the function required, such as delay, mobility, capability, and reliability, and data rate. Or maybe for particular users, such as MPS user, public safety user, customer user, roaming user, or even the MVNO user. So network slicing can provide a whole network function, including wireless connection, and also provide all kind of network slicing, network slice. Because fifth generation going to use a high spectrum, so the coverage range will be smaller than 4G. Therefore, the base station, the total number of base station 5G will be much more than before. But in order to lower down the deployment expense, how to sharing the access network or doing the co-constructing will be a challenge. So several countries have been doing that. However, who to build it, who invest, who maintain it, who will take over those bills, to provide service, it will be quite a lot of challenge for all those vendors to need to talk about. And this paper provides 5G communication, wireless communication, very typical environment, and massive mobile connection and ultra reliable low latency connection need to connect it to quite a lot of IoT devices, and massive machine type communication, and enhanced mobile broadband, and URLLC. You can see all different challenge. You can, if you are interested, you can take a good look of this paper, of course. 5G America, the white paper also point out that there are 3 different directions for home to home, home to machine, but I'm sorry, human to human, human to machine, machine to machine, different using. And there are several applications for 5G. One is using 5th generation onto agriculture, so that you can providing a more intelligent agriculture. For example, in our campus, we have a very close cooperation with a local farmer, because they are always fond of planting watermelon. However, it's really very tedious and very time consuming, and also manpower consuming to trying to figure out how many watermelon totally we have, because whenever you are trying to sell it, you should have a rough number totally how many watermelons. So therefore we are providing them using the UAV or the drone to fly up to the sky, and then using all sort of IoT stuff, or using those camera to take the picture and then calculate the total number of watermelon for the farmers, and make sure the error rate is within 5% or 3%, which the watermelon dealer will accept that kind of error rate. And this is a 5G teleoperated driving with Huawei.
5G is coming for a super connected world. The car industry is one of the first verticals to take advantage of cutting-edge 5G solution for improving road safety. Huawei is spending...
And of course, that's a 5G smart factory, 5G
as part of
UAV,
our research and standardization
and
in
5G
for
XR.
5G.
World's first drone. All different kind of 5G regarding healthcare and all those things, medical increase, being using quite a lot. Now I'm trying to bring you a rough idea for why we're going to move to 6G, because to be honest, 4G is quite enough. Okay, we can take a look of high resolution film such as 4K easily using 4G already, and almost we can connect to everyone, everywhere, anytime. However, we all still demanding for 6th generation. What really want, because when those AR, VR, virtual reality, augmented reality, and intelligent self-driving car are so popular, therefore quite a lot of data transmission and storage being generated. For example, for medical purpose, almost every person, if you put some wearable devices and maybe implant some intelligent devices into your body, for each individual, every second you can provide 1 terabyte up to 10 gigabit per second, 1 terabyte static and 10 gigabit per second dynamic information. If under the emergent circumstance, it will also demanding high-speed moving and on-time live transition, on-time interconnection with the hospital, and I guess 5G is still a little bit difficult to meet this requirement. And at the same time, the spectrum is limited, so how should we squeeze even more spectrum or using MIMO and millimeter wave to solve the spectrum problem? However, as we always know, using millimeter wave, the coverage range will be shortened than before, and so that intelligent spectrum sharing, co-constructing, as I mentioned before, will be become necessary. And at the same time, from 1G to 4G, we are always using the cellular networking. Therefore, one of the main reasons is that we may increase spectrum usage efficiency, and therefore your capacity will be also increased. However, using the cell phone structure and also complicate the spectrum management and complicate the end user get into the mobile system, and at the same time how to deal with that, because it will certainly block your improvement or development for 5th generation. So maybe in the future, supercell will be the key core idea for the 6th generation. There's several supercell you can take a good look, and using Google, you can take a good look to see what's going on in the future. And based on the ITU-D, 5G enable industry demanding even more vertical application usage, such as intelligent IoT, or maybe even AIoT in the future. So at this time, although we are already demanding as low latency, as low as possible, into 1 millisecond to 10 milliseconds. However, in the future or at this time, some sort of specific requirement even demanding peer-to-peer latency to as low as 0.1 millisecond, and also even lower to 0.02 millisecond, which really will bring a lot of challenge to 5G, and that's what 6G is going to deal with. Another reason is that currently our wireless communication only cover 70% of the population on Earth and 20% of the land area, but you cannot ignore that there are still 80% land area and 95% ocean area without any signal coverage. Therefore, integrated space terrestrial satellite communication and the satellite Internet of Things must be introduced to solve this problem. And how to compatible with these two technologies will be a very big challenge, because in the space and also trying to solve underwater communication, there will be quite a lot of technology challenge on that. For example, the figure on the top the left-hand side is an integrated space terrestrial satellite communication structure, and the satellite can be divided, can be grouped like a LEO, MEO, GEO, and the right-hand side, when you're using drone-assisted cellular network, and using that, combining with those satellite communication in order to increase your coverage area. And mobile cellular network today covers only 60%, as I just mentioned, and so we have to try to cover. But one of the good news is the founder of the Tesla, Musk, just released that SpaceX can provide downlink regarding approximately 140 megabit per second, which is very, very fast, those kind of satellite communication comparing to satellite communication. And in the future, SpaceX and Amazon are going to launch quite a lot of low orbit satellite and trying to achieve the so-called everything together, X on internet, XOT. However, there will be still a lot of challenge for beyond 5G and 6G, like a security problem and contradiction between complexity and reliability, the relationship between artificial intelligence, which is very hard now, and those are between artificial intelligence and 6G development. Now, development IoT, I will go through it very quick. Okay, the first IoT have been introduced in year 1974. What's that? It's a ATM machine, right? In 2015, already those kind of devices being increased 233%, and we are expecting in the end of this year will be even more than 250,000 devices being introduced. So quite a lot of IoT devices will be implemented, such as a water meter, electricity meter, gas meter, things like that. So in order for that kind of purpose, one of the 5G fifth generation user case is a massive device connection. Currently, 4G is not able to do that. So IoT devices will be using light spectrum and unlicensed spectrum, or even the LoRa unlicensed spectrum to solve the IoT devices problem. Make sure 3GPP can move into this market. And currently, for fourth generation, LoRa has a there are two main technologies for IoT connection, LoRa and BIoT. I guess LoRa is basically for application purpose, and BIoT is for coverage purpose. So LoRa using a licensed band, and BIoT using a licensed band, and supporting by all those service providers, traditional service providers. So I guess NB-IoT will dominate the market sooner or later. If you're demanding more bandwidth, then you can still using the massive enhanced massive type communication to provide you even more bandwidth than NB-IoT. Here are the example by merging the IoT and the fifth generation devices. Will be the IoT application, including smart city, industry 4.0, and using LoRa and BIoT can be connected to the internet. And there will be a lot of platform and infrastructure to collect those information gathered by those IoT. And through this platform, we can develop all kind of application, all kind of service to our users. And smart city, I guess everyone should be very familiar with that, I will skip that to smart healthcare. I guess health plus big data platform with help of the artificial intelligence. A lot of people may get jobless in the future because they are considering a lawyer, doctor, can be replaced by those artificial intelligence. And of course, there are a lot of Internet of Things challenge for Internet of Things. Security and privacy will be things like that. As long as you put so many intelligent devices around you, your privacy and security will easily be revealed. For example, you're using Google Map. Every month, Google Map will provide you your pass for the whole month, your road pass, driving pass, in the whole month, where you driving from where to where, which city you been staying, and things like that. Once this kind of information being released, then everyone know where are you going, where you were going, and where you have been staying. That's the problem of the modern world, of course. And beside that, quite a lot of unit being installed. Those internets. Gartner predict that IoT devices will be, as I mentioned before, will be to 26 billion. And so along with those billions of devices, quite a lot of garbage information being gathered. Now we're using cloud to lower down the cost. However, if you put everything on the cloud, you will lower down your efficiency for sure. Therefore, Cisco has provided so-called fog computing, and there's what is fog? Fog computing is something like edge computing. However, the only small difference between fog computing and edge computing is that fog computing edge computing try to push computing and storage as to the user end as possible, but fog computing will somehow in between. So that's what deep learning can kick in to play an important role to decide it, which part should be put in the cloud, which part should be put in the fog. And here is an example when you're using fog computing. If you're in a stadium, you miss the important shot when the player shooting the ball. However, you want to replay those important moments, and within the stadium there will be maybe 1,000 people demanding to replay those important moments. And fog computing can easily solve the problem. And when you're using fog computing, you can lower down your loading, and when you're using virtual reality because virtual reality need quite a lot of image recognition. Those image recognition will be stored in the cloud, and of course it will delay your augmented recognition. So if you combining augmented recognition and fog computing together, and of course you will decrease the delay. I guess self-driving car is another important application for computing. So challenge for computing is like as before. One I mentioned only several of it. Edge caching. The first is edge caching. What's edge caching? That means how big your fog should be. If you put your fog to be as big as cloud, then what do you need a fog for? And there are also discovery synchronization, centralized points, and standardization issues. Quite a lot of standardization issues. And development of AI, because my time is quite going to run out. So I guess all the people should be quite aware of the deep learning nowadays, divided to be 3 different important algorithms: supervised learning, unsupervised learning, and things like that. I guess this should be very important because it combine all different topic for network in mapping to some specific deep learning method, such as access point selection will be considered as a supervised learning. D2D communication will be considered as a unsupervised learning, things like that. And also, there are quite a lot of different algorithms belonging to 3 different learning stuff. You can take a good look. Okay, here is the deep learning platform we've been built for the past 3 years. And the first year we are trying to deployment of deep learning platform, and the second year we implement all kinds of network function I mentioned in the early of this speech. And finally, for this year, we're trying to finalize to provide a self-organization deep learning platform. As you can take a good look, when we deploy the deep learning platform, we separate into the B5G access layer. This layer we've been built already, and then we're trying to build the core network layer, because the B5G access layer belong to the first 3 years, 7 years ago, the project 7 years ago. So, and then recently, we are going to, or 2 years ago, starting from 2 years ago, we're trying to install the core network layer and deep learning service centers. As you can see, this is the process of deep learning platform. It divided into data processing platform and data training platform. Data pre-processing platform. The main function for data pre-processing platform is trying to to analyze the data and trying to set up the model. Data training platform is trying to do the deep learning calculation, and so information will be goes through the edge server to do the data pre-processing, and this kind of edge server can be co-located with the base station, so that can provide because base station can provide limited computing resources, such as you're using your cell phone, notebook, PDA, things like that. And through those 4 computing technology or function, so we can avoid all the information coming from or going to the cloud. You will use up quite a lot of your traffic. And after those pre-processing, this information will be uploaded to the cloud server. Cloud server will depend on different kind of network requirement, using different kind of deep learning method to do the model training. After the training, model will be sent back to the base station, prepared to be used in the future. And so the second stage is trying to data training platforms and data pre-processing platform is 2 independent platforms. And in order to make them to be do those automatic deep learning process, we have to couple these 2 platforms together. And so after beyond 5G platform can use those model directly, and how to make sure they to be local maximized, and how to increase the deep learning efficiency. So we are also how to improve those work functions, such as fog management and traffic classification for security and core network and mobility management and edge computing, hotspot management, things like that will be these functions can be using to enhance your deep learning process. For the third year, we are trying to make sure our deep learning efficiency to be as good as possible. So our deep learning platform using GPU, TPU to do the load balancing, and also there will be network access management and collecting all those data, big data, and trying to analyze it, and providing security management and core network management, and edge computing management, and mobility management, and interference between base station. Also trying to make the whole thing to be even better than before. Here are the self-organizing deep learning platform and providing all those network function as I mentioned. And here are the platform we've been built. Okay, according to the network structure, we have a CRAN and using user N, using a SIM card, and the station using a Huawei use cell phone. And because we are using the so-called physical administration function, we can easily change the registration information on the SIM card. So whenever ENO-B connected with the evolved packet core, they will automatically get into the home subscriber and trying to see whether there's the information is correct or not. If they cannot find the SIM information, we will reject the connection. And here are some integrate edge computing and cloud computing together, and you can see that easily see that. And here are several examples. We have actually built those CRAN, ENO-B, and evolved packet core. And these are those pictures regarding all those stuff. Live picture we've been built. And here are some particular example. When using Wireshark, you can take a good look of MME, the communication between MME and the ENO-B, and OAI, and all kind of signal message. You can take a good look of that. So and OAI will gather those radio frequency like a receive signal and channel frequency response, and the so-called physical uplink control channel and physical uplink share channel. Those information will be recorded, and by looking at those information, and those you can take a good look of signal strength, and the so-called channel quality indication to see the signal quality, and therefore base station can allocate the resource block, the better resource block, so you can gather a better transmission efficiency. Here are the example. We are using YouTube and the speed test to see what our platform been doing, and you can see that after we're playing the tape, the maximum downlink will be 32.5 megabits per second, uplink will 4 megabits per second. However, if you are demanding a lower connection speed, will be 0.5 megabits per second. Apparently, end user devices will be influenced by OAI parameters such as transmission, receiving gain, and reference signal power, permorbital initial received target power. And so therefore, we gather all those information and put it back to our deep learning input information and trying to train a model that in the future we can provide appropriate resource to the appropriate demand or requirement. And we're using mobile NetBeast version 3 CNN lightweight model to predict the network connection. We are a little bit better than convolution LSTM, but the training time and parameter have been reduced quite a lot. This is the throughput of 2 different base stations. And roughly speaking, we can predict the traffic change. And for our subproject 2, we are developing deep learning-based security fuzzy testing functions or testing tools. Through this, through this figure, you can easily see that after we're connecting several different end-user devices such as Qualcomm, Snapdragon 630, 800, 810, 820, 835, and Intel and Qualcomm, since that, the result shows that the proposed system can generate and cover more than 90% of protocol of beyond 5G mobile connection access network into it. That's quite a acceptable result we can have. And by collecting all different kind of payload through the deep learning to distinguish the user service into such as NB-IoT or UAV or 4K videos or even Facebook. So then later on, we're using CNN-based method to divide the packet and try to test the different payload size. And you can see that the accuracy is pretty high. And combining with the edge computing with IoT and AI, and putting your AI model into those edge servers, we can provide some sort of real-time services, such as left-hand side is our subproject 4 system structure. It's been divided into 3 layers. The first layer which should be IoT devices. The second layer is MEC. The third layer is cloud. So we're using MQTT broker because all kind of different edge devices may using different protocol. So MQTT broker can easily communicate with different IoT devices, and so that IoT devices and edge server communication can be easily achieved. As you can see from this diagram. And interference between base stations is quite important for beyond 5G or 5G beyond 5G. So building interference into terrain interference and large obstacle interference by using CNN model to do the base station deployment. Try to avoid those interference beforehand. Okay, here's my conclusion. The edge computing is very important for even 5G and beyond 5G. And different network use have appropriate deep learning algorithm. Integrate edge computing and cloud computing is expected to provide greater performance and efficiency for beyond 5G platform. And there are many applications can be implemented on beyond 5G platform, which based on edge computing and AI, such as security management, interference management, access point selection, mobility management, and so on and so forth. Okay, then there's about all I'm going to talk, and 5 minutes above my time. And again, Donghua University is only 26 years old, but we are standing firm and trying to make sure our campus is to be globalization. And thanks for listening. And hopefully I can see you all on campus, or even better, I can see you in the world in a couple months. After a couple months, the pandemic is really hurting us. I've been house arrest or been grounded for exactly 1 year till December 30th. So I'm looking forward to seeing you all in the world soon. Thank you so much. Bye now.